Okay, so today we are working on assignment 12.2. So assignment 12.2 is a revision of chapter 8. So we'll be focusing on numerical problems from chapter 8. And let's look at question number 1 from assignment 12.2. So in this question, it is asking what is the distance between two pellets that have the charge of 1.2 microcoulomb. Micro means 10 to negative 6 coulombs. Okay, so that's the charge in this pellet, and there is also 1.2 times 10 to negative 6 coulombs on this pellet, and they exert force of 10 Newton on each other, and they are at some distance d apart, and we want to find that distance, what that distance is. So we will use this formula for the force between two charged particles. So force is equal to some constant k times q1 times q2 over distance squared. So we want to get this distance, so that means let's take this distance to the left. So what we can do is we can multiply both sides by d squared, because I want to move this d squared to the left. So cancel d squared and d squared, and then I want to get rid of this f on the left, so divide both sides by f and f. So now I cancel f and f, so we are left with d squared on the left, and then on the right we have k q1 q2 over f. Okay, and then in order to get d, because we have d squared here, I can take the square root on both sides. So I can cancel this square and square root, so then I will have d, and then we have k q1 q2 over f. So we want to get d. Now plug the numbers in this expression. K, the value of k is a constant, it's 9 times 10 to 9 Newton meter squared per coulomb square, that's the unit for k. And the charge is 1.2 times 10 to negative 6, and q2 is also same, so 1.2 times 10 to negative 6, so 10 to negative 6, and then all over force is 10 Newton. Okay, so now we need to do the calculation. So first of all, you can calculate everything inside the square root, and then you can take the square root, or if you have a scientific calculator, you can just plug in all these terms. So you can take square root of 9 times 10 to negative 9 times 1.2 times 10 to negative 6, and that times 1.2 times 10 to negative 6, and that over 10 Newton. So let's see. 10 to not negative 9, so 10 to 9 for k. The value of k, I plugged in negative 9 for value of k, so the value of k is here 10 to 10 to 9. So that gives me 0.036 meter. Okay, so that's the distance. Now let's look at the second problem. So let's paste it here. So that's the second problem. So how much charge flows through a wire carrying 2 amperes of current? So they have a wire that is carrying some current, 2 amperes, and so the current, flow of current means there is flow of charge. Okay, current means there is some flow of charge in this wire, and we want to know how much charge is flowing in 60-second time. So we have this definition of current. Current is charge over time. Okay, we want to find charge, so multiply both sides by T. That means you can cancel that and that, so that means Q would be I times T. So I is 2 amperes and time is 60 seconds, so that gives me 120 coulombs. Okay, the unit for charge is coulombs. So that's the amount of charge we have, or the amount of charge that is flowing through this wire in 60-second time. Now, how many electrons is this amount of charge? So, or in other words, how many electrons are there in this amount of charge, given that one electron has 1.6 times 10 to negative 19 coulomb of charge. Okay, so one electron has that much charge, then how many electrons are there in this much charge? So the number of electrons is total charge. Let me just plug in the numbers there. Total charge, which is 120 coulombs, over the charge in each electron, which is 1.6 times 10 to negative 19 coulombs. Okay, so when I do that math, what I get, 120 divided by 1.6 times 10 to negative 19, that gives me 7.5 times 10 to 20th electrons. Okay, that's the number of electrons. Now, just a caution that when you do this math in your calculator, so when you divide this 120 coulomb by that, you need to put the parenthesis for that. Otherwise, if you don't put the parenthesis, this multiple sign will be this will go on the top here. Okay, that's not what we want. So we want to divide this 120 by this whole thing. Okay, so you need to put the parenthesis there. So that's number 2, and let's look at number 3. So the wattage marked on a light bulb is not an inherent property of the bulb. Rather, it depends on the voltage to which it is connected, usually 110 or 120 volts. How much current flows through a 100-watt bulb that is connected to a 120 volt power outlet? So the watt rating is basically the power of the appliance. Okay, so whenever you see 1000 watt or 100 watt, that means that's the power. Okay, so we have power of the bulb is 100 watt, and it is connected to the voltage of 120 volts, and we want to find the current. Okay, we know the relationship between power, voltage and current. So P is V times I, or I times V. We want to find I, so I want to move this V to the left. So for that, let me divide both sides by V. I can cancel V and V, then I will get P over V is equal to I. So I can find I by dividing P by V. P is 100 watt and V is 120 volts, and that gives me 0.83 amperes. So the unit of current is amperes. Okay. Now let's look at number 4. So an electric dryer connected to 120 volt source draws 8.4 amperes of current. How much heat is generated in 90 seconds of its operation? So this heat means is the energy. Okay. Now we have two formulas for power. So power can be written as I times V, and power is also defined as energy produced per unit time. Okay. Now we need to use both of these formulas to find the energy. So basically we want to find this quantity. So let's first find the power from the first formula. So power is I times V. I is 8.4 volts, 8.4 amperes, I mean, times V is 120 volts. Okay, so that would be 8.4 times 120, that is 1008. Power is expressed as watt, in terms of watt. So we got the power. Now we need to find the energy. So we have this formula, energy over time is power. We can rearrange this formula. So then E would be power times time. So power is 1008 watt, and time, it says for 90-second time. Okay, so you use the dryer for 90 seconds, and then that will give you the energy. So that times 90 is 90,720. That's the energy, and the unit for energy is joules. Okay, so 90,000 could also be called 90,000 kilojoules. Okay, so 90.7 kilojoule is 90,720 kilojoules. So this is 90.7 kilojoule. Kilo is times 1000. Okay, 1 joule, 1 kilojoule is 1000 joules. Okay, so let's look at number 5. So on number 5, we have a certain device that is connected to 120 volt. So V is 120 volts, and the current in that circuit is 12 amperes. So we want to find the resistance. Okay, and we used the Ohm's law last time. So Ohm's law tells us V is I times R. Okay, so we want to find I. You rearrange that, you get V over R. So V is 120 volts and R is, sorry, we want to find R. So we want to find R, so we can rearrange this as R is equal to V over I, and then V is 120 volts, I is 12 volts, 12 amperes. That means R would be 10 ohms. Okay, that's the unit for, this is ohms, that's the unit for the resistance. So we can also write 10 omega. Omega is the symbol for ohms. Let's look at number 6. Okay, so we want to find the cost of operating 100 watt bulb for 1 week. So when we get the electric bill, electric energy bill, so the energy in the electric bill is expressed in kilowatt hour. Okay, so we need to express the unit of energy in kilowatt hour. In this case, we want to express the energy in kilowatt hour. So we know the power is energy over time, energy per unit time. So we want to get energy, how much energy we are using. So energy is time, power times time. Okay, so power is 100 watt and time is we are using it for 1 week. That means 1 week has 7 days and each day has 24 hours. So 24 hours over 1 day. So that means we have 1000 watt times 7 times 24 hours. Okay. Now again, we want to express our energy in terms of kilowatt hour. So we have hour here. Now we need to convert this to kilowatt. Okay. So the way to do that is, so this is 100 only, sorry, not 1000. So way to convert from watt to kilowatt is dividing that by 1000. If I divide that by 1000, then watt becomes kilowatt. Okay, that's the conversion. So divide this by 1000 and that becomes kilowatt. Okay, times 7 times 24 hour. Okay, so I can cancel these two zeros and these two zeros. So I need to multiply 7 times 24 and then divide that by 10. So let's see what we get. So 7 divided 7 times 24 divided by 10, that is 16.8 kilowatt hour. Okay, or we can also sometimes say this to be 16.8 units of electric energy. Okay, we are here consuming 16.8 units of electric energy, and each unit costs 12 cents. So we need to find the total cost by multiplying this and the cost of 1 unit of electricity. So that means the total cost is 16.8 units times 12 cents, 0.12 per unit. So unit and unit cancel. So 16.8 times 0.12, that would be $2.02. Okay, so that's the total cost. Now let's look at number 7. So we are looking at number 7. So we have three bulbs, bulb A, bulb B, and bulb C. So, and the bulbs are connected to a battery. This is a battery. So it's asking to rank the current from greatest to least through each of the bulbs, and also rank the voltage in each of the bulbs from greatest to least. So let's first think about the current. So when the bulbs are in series like this, then this path offers the greater resistance. Okay, so this one has greater resistance to the current, and this one has this one offers less resistance. So more the light bulbs, more is the resistance to the current, and we know that greater the resistance, or I should write, so greater the resistance, less is the current. That means bulb C will have the greatest amount of current because it has the less resistance or least amount of resistance. So C would have the greatest amount of current, and then that will be the greatest one, and then A and B, because they are identical bulbs, so although the current through A and B is less than C, but they will have the equal amount of current, A and B, because whatever current goes through this bulb, same amount of current will also go through B. Okay, so that's the ranking for the current. For the voltage, so when the things are in parallel, the parallel branches get the same voltage, meaning the voltage of the battery here will appear across these 2 points. Okay, so if it's the V here, this one will have V across it, and this branch will also have same voltage. But in this bulb, all this voltage is dropped across the bulb. Okay, this will appear across the bulb, so it doesn't have to share with any other bulbs, so everything would be appeared across that bulb. But here this voltage has to be shared with these two light bulbs, so that means part will go to this one and part will go to that one, because they are identical. That means half of this V would go here and half of that would go here. So that means this one would have the greatest voltage, and then A and B will have the same voltage, but it would be less than that of the C. Okay, so that's the ranking. Now let's look at the last one, number 8. So we have identical bulbs, so we have bulb in this circuit, bulbs in this circuit, and bulbs in this circuit. So we want to rank the voltage. So these are the meters that measures the voltage, and we want to rank the voltage measured in this circuit, voltage measured in this one, and voltage measured in this one from greatest to least. Okay, again, just like before, the voltage of the battery would be shared among these three bulbs here. The voltage would be shared between these two here, and the voltage appears on only single one. That means this one will have the maximum voltage, so A will have the greatest amount of voltage across it, and then next one would be B, and then C would have the least amount of voltage because the voltage has to be shared among the three. So that's our ranking.